Okay, so make sure you have your calculators ready because there will be, you're going to have to solve. When you're asked to solve, so there's that key word, right? If the question asks you to solve a quadratic, what it's essentially asking is you need to determine or find the x-intercepts. Okay, that's what it's asking you to do. And I think that's worth highlighting, that whole statement right there. Solve means find the x-intercepts. So maybe on your study sheet say solving quadratic, find x-intercepts. Just a quick way to know. And also note that x-intercepts are the same thing as roots. And you're going to know why in a bit, because we square root to find it if we do it algebraically. So x-intercepts, the same thing as roots, is the same thing as zeros. It's the same thing as solutions. Right, so they all mean the same thing. So if I ask you how many roots are there, it's asking for the number of x-intercepts. If I ask you to, hey, find the zeros, I'm asking you to find the x-intercepts. How many solutions, right? Find the x-intercepts. So that's what it is. There are two methods of solving quadratics. One is by using the quadratic formula. That's what we're going to start with, and then tomorrow or maybe a little later today is using the graphing method. Okay. So let's do the quadratic formula. Here's the formula that you need to copy down, and you need to have this on your study sheet. Okay, so I'm going to make sure I have this. So in this box, so to find the x-intercepts, I'm going to put everything in brackets. Okay, that's technically, if you ever get a formula in physics, chemistry, doesn't matter, you always assume that the letter has brackets around it. Okay, so you're going to insert it there. So let's say you have a negative value for b. Guess what? That negative will meet this negative, turns this whole thing positive. Okay, that's always the case. Plus or minus, and then it's a long root here. Okay, inside that root, you go b squared, so you square whatever b is, plus, sorry, not plus. Can you please erase that? I hope you didn't use pen. My bad. Minus 4 times a times c. And my root is a little too long, but that's okay. Doesn't hurt. Okay, all of this, the whole thing, and I'm going to use a red pen for that because some students forget. They only put the line under the root, but it's the entire thing. So the whole result you're going to get there, right, is going to be divided by 2 times a. And you're like, where are all these letters coming from? Well, remember, if you're given this equation, which is in general form, right? If you have it in general form, meaning no brackets, then whatever is in front of x squared is called a, whatever is in front of x is b, and whatever is just on its own is c. So we use those numbers and plug them in as follows, and then we find our x-intercepts. Okay, so you're literally, this is how you do it by hand. The part that's inside, the b squared minus 4ac, is called the discriminant. Okay, and so this part inside here is what we call the discriminant. And why we call it the discriminant? Because it discriminates. It tells whether or not the parabola, if whatever is inside the root, if you type this into your calculator and you get a positive answer, okay, so positive, that means that this parabola will have 2 roots, or we can call it solutions as well. if it's equal to 0, one solution, or root. Remember, these are all x-intercepts. And if it's negative, there's going to be no roots. Okay? No roots, no solutions. For study sheet purposes, maybe you want to have this formula there, and then just say that, right? Just have these 3 arrows come off of this, and just say, hey, if there's positive, 2 roots, 0, 1 root, negative, no root. Maybe, like, because I'm going to ask you sometimes, why does this not have a root? Why is there no x-intercept? Because it's negative, right? So you've got to be able to know that. Okay, let's use this formula to find the x-intercept. So again, we're using this to find the x-intercepts by hand. Okay, so let's go to 21. Solve the following using the quadratic formula. Okay, I'm going to copy the quadratic formula one more time. This time I will not use brackets. So if I ask you to use the quadratic formula, you have to show the quadratic formula, okay, how you're using it. That's the point. I know you can use your calculator to find the x-intercepts, okay, but I want you to use this. What is y equal to if we're trying to find the x-intercept? 0, right? Yeah. So whenever there's a y, you just let that equal to 0. Okay. You just turn that into 0 because we're trying to find, so y is equal to 0 at the x-intercept. That looks really bad there. Hold on. Y is equal to 0 at the x-intercept. So that's just a little note there. That's why that turned into 0. So you essentially now have 0 is equal to 3x squared plus 3x minus 3. This is the easiest case here. It's just already set up. You don't have to do any foiling. Nothing like that. Everything is the way it's supposed to look. Okay, so A is equal to 3, B is equal to 3, C is equal to negative 3. Okay, so you just read off the numbers in front of your variables. Question, is there a possibility that you had something like this? What's C then? 0. Okay, C is 0. If it's not there, C is 0. So that's what you would do here. If the 3x is missing, if the whole x term is missing, then B is 0. Okay, so like if there's no x term, that means that B is equal to 0. That's why x disappeared. Okay, so it doesn't happen very often, but just be ready for it. So here we go. Let's use that formula. X is equal to 3, so it's actually negative 3 like this. Plus or minus. I do use brackets when I insert, okay, when I substitute in. So 3 squared, it's calling for b squared, right? Minus, this minus is always there. That's part of the formula. Okay, you cannot change that. 4 is there, and then a is 3 as well. And the c is negative 3, so watch that. So that's what you plug in there. And then all of that, it looks scary, but it cleans up pretty nicely. 2 times a. And a is 3 here. Okay, so let's clean this up now. Basically, I get rid of all the brackets. So negative times 3 is negative 3. plus or minus, and inside the root, you're just going to come up with one value. So grab your calculators. I'll show you how to type this in. If you don't want to guess, if you don't want to have to worry about signs, then use brackets. So it's 3 squared, just like that, minus, not negative, 4 times 3 times negative 3. So when it's actually inserting a value with a sign, you have to use the negative button, the one in brackets. Okay? And then hit enter, and you get 45. By the way, just a little note, this is positive. Therefore, how many roots? I'm expecting 2 roots. And now you know why we call them roots, right? Because it's inside the root, okay? So that's why we do that. And then over 2 times 3 is just 6. And so this cleans up pretty nicely. So now you probably wondered, what's the plus and minus all about? Well, one root will be found by 3 plus whatever is in here divided by 6. And the other root is going to be negative 3 minus 45 divided by 6. That's how you get your 2 roots. Okay? That's why the plus or minus. Otherwise, I'd have to give you this formula twice. One with the plus, one with the negative, and that's just too much work, right? So this is, so from here, this is kind of in the way a little bit, but that's okay. So from here, I branch out. Anywhere on your paper, wherever there's room. So I say that the first root is going to be negative 3 plus root of 45 divided by 6. And you have to be careful here how you type that in. So grab your calculator and you just go negative 3. So negative 3 plus the root button, right? Second, x2, 45. I hit enter at this point. And then I divide that by 6. So my first root is 0.62. So you literally found the x-intercept, the first x-intercept of this parabola. And then the second root is going to be x2, and that's negative 3 minus root of 45 over 6. And your calculators they allow you to copy and paste. So if you want to do it that way, I just go up to the previous entry, I hit enter, copy that expression down, and I just change the plus to a minus. Right? So then you have this part right here. Enter, and you divide that by 6. So it's negative 1.62. So that's your second x-intercept. Okay, so you have both x-intercepts. We knew we had 2 because whatever's inside the root is positive. If whatever's inside the root is 0, you only have 1 root. And you can tell why, right? Because negative 3 plus 0 or negative 3 minus 0, you're going to get the same answer. So even if you did this twice, your answers will be exactly the same, at which point you will realize, oh, wait a minute, there's only 1 root. Okay, there's only 1 x-intercept. Okay, variations. There's some times where you have to bring stuff over. Okay, so I will help you out with arranging it, but then I want you to actually try this on your own, figuring that out. So let's try that second one there. So basically what I tell my students, bring everything over to one side. I tend to bring everything over to the left-hand side. So for example, I would go 8x squared. The 3x squared, when it comes over, it changes sign. So that whole expression goes negative 3x squared. Some of you would rather subtract 3x squared from both sides. That's okay. If that's how you were taught, it's okay to do it that way. Next is the 5x. And this negative, so I'm going to actually do this. I'm going to circle this and say that came over to that side. I'm going to circle this and also saying that it came over to the other side. So the 4x is negative on this side. As soon as it crosses the equal sign, it turns positive 4x. And then the 7, which was already on the left-hand side, just stays, plus 7. And then you're left with nothing on the right side. And now you combine your like terms. 8x squared and negative 3x squared, that's 5x squared. 4x and 5x turn to 9x. And then 7. So these are just variations of what we've just done. So basically what it means is you got to do a little bit of extra work to get it to look like the general form. And now you have A, B, C. As soon as you have equal to 0 on the other side, you're done. Okay, you can go ahead. What would you do if there was a y somewhere? You turn it into 0. Okay. If there's a y anywhere, turn it into 0 if you're using the quadratic formula. So I want you to use the quadratic formula. Knowing what A, B, and C, it's probably a good idea to write it out. What are the 3 numbers that I'm going to be using? And please don't rush this step right here, because it's very frustrating, right? If you get even a sign wrong, everything is going to be off. So make sure you show your work here as you rearrange. Maybe I'll just say here, rearrange. Right? This is an example where you had to like move stuff to make it happen. And sometimes you have to FOIL before you rearrange, right? As soon as there are brackets, guys, you gotta multiply it out before you start moving stuff over. Okay, so use the quadratic formula to do this one. And if you're comfortable, start C as well. And I'm gonna just make sure that if you have any questions, that I address them. I will just say this. Just give it a try. See what happens. I'm just going to quickly show you here. So this one would be negative 9 plus or minus 9 squared minus 4 times A times C, okay? And then all of this is over 2 times A. And just make sure this division happens at the very end. It's not inside the root, so don't be mixing things up here. Don't be dividing that. Don't worry about it just yet. Clean this up. You get negative 9 plus or minus. When you type this in, you get negative 59. And that is a problem, right? Did your teachers tell you can't take the root of a negative number? Yeah, that's a bit of a lie. If you do calculus, we call them imaginary numbers. That's how desperate math people are. They just imagine things. Anyways, you stop there, okay? So no roots, right? Because the discriminant, is negative. You just can't do it. And so what does that mean? This one never crosses the x-axis. This parabola just doesn't cross it. That's all it means. Okay. Nothing wrong with the parabola. The parabola, we still love you, parabola. It's just you don't cross the x-axis. There we go. Next, here you have to FOIL it. So you have to do distribute that out. So 3x times x is 3x squared. 3x plus times plus 2 is 6x is equal to negative 3. That's step number 1. Then I bring this over to the other side. So 3x squared plus 6x. Do I go negative 3x, or is that wrong? That's wrong. When you cross over, you change sign. Okay? I'm just going to do this just so you have another example. 6, right? Negative 6 plus or minus 6 squared minus 4 times A times C, all of that over 2 times 3. If you clean this up, it ends up being negative 6 plus or minus. This gives you 0, okay? So what does that mean? Yeah, only one x-intercept or only one root. So don't go plus 0, minus 0. You can actually ignore the root of 0. You can go plus 0 if you want. It's not wrong. But you can just say there's only one root, and that's negative 6 over 6, which is negative 1. So you found the only root that is negative 1, 0. What does that mean if there's only one root? The vertex is on the x-axis. That's the only point that's touching. Okay, so you found an x-intercept. This is also the vertex. Okay, which way is this pointing? This is pointing up, right? So it's somewhere. This is negative 1, 0, so it's somewhere there, and it's going to do that. Okay, graphing method. I think I'm going to stop here. To practice, because you need to practice, I think there's going to be a few that are going to involve a bit more work. So I'm going to say 26 to 28. That's a lot of work. Listen to this part. I want you to try one on each page. Okay, each of them has a different level of difficulty, and just try one of each for sure. Must. Okay. If you feel like, you know what, I need more practice, you do the second one on each page, because each page has 2. So the very first on 26 just has 2. You just have to move stuff around a little bit. I mean, the first one you have to move nothing. So maybe if you pick this one. Okay? And then 27. Ooh, brackets, right? So stepping it up just a little bit. And then 28, more brackets, right? Because you all like brackets. Don't worry so much about what it says up here. Just use the quadratic formula every time. Use the quadratic formula. Don't worry about exact values. Like, I don't know if you remember from intro, exact values. You don't root anything, you just leave it. Don't worry about that. You just go ahead and use the quadratic formula, find the answer to 2 decimal places, okay? If possible. I don't know if they're all possible, right? And I will post the answer keys, and that should be good practice for tomorrow.